Chapter 11, Wide Area Networks. Up to now, our studies throughout this course really have been focused on the local area network, the area that as network administrators represents our own infrastructures, the equipment that we own, or our companies own anyway, and our area of direct responsibility. This week, we're going to look at the wide area network. I mean, arguably, the internet is really nothing but all our little LANs connected together over the largest wide area network in the planet. So there's a few things going on here, and we're going to look at those. Now, WAN and LAN have some key differences behind them. Mainly, LANs connect nodes, compute nodes, computers and printers and servers and smartphones and all that kind of stuff. Smartphones on Wi-Fi, that is, right, over wireless. Whereas WANs connect the networks together. Okay? So a lot of the layer 1 and layer 2 technologies we discussed previously, the physical and the data link layers, change. We're going to see a lot of parallels between the two different techniques, but fundamentally they are different. A few terms to talk about. WAN site is a specific location on the wide area network, an office, a campus, whatever. It's a local area network that is joined to the WAN. WAN links, obviously, are the links between multiple WAN sites. A WAN site of one isn't very useful to me. I need to at least have two. We see two terms kicked around throughout this week, and you'll see this again as you're out in the field. This thing called DTE and DCE. Well, DTE, what it means is data terminal equipment, and that's the customer's data. If you're the company, that's where your equipment connects to the wide area network. That's the last piece of your property that talks to the WAN. And the DTE talks directly to your local area network. What does the DTE connect to? Something called Data Communications Equipment, DCE. DCE is owned by the provider, the ISP. And it's the first ISP device on the WAN. So whereas the DTE provides communication back into the privately owned LAN, the DCE provides communication to the publicly owned wide area network. These two devices are the ones that talk to each other. Now we can look at sites, right? Sites can be anything from the many sites that makes up the internet to more private network type of sites, like what we see right here. Right, this might be a wide area network for a privately owned company, and they have offices in San Francisco, Detroit, New York, Miami, and Houston. And these network links that connect each of the offices, those are the WAN links. We discussed the DCE and DTE already. Here's a prime example. Here's two sites. This is site number 1. This is site number 2. In this cloud in here is this big thing we call the interweb, the internet. DCE, owned by the provider, which in this case, let's say, is a quote-unquote cable modem. The cable modem is connecting to the cloud. And the DTE, which is a router, firewall, whatever, owned by the organization, connects directly to the DCE. See what's going on here? Public network. ISP land, private network, local area network, local area network. Now, like LANs had topologies, we had bus topologies and star topologies and ring topologies and mesh and all that. We have it too. And actually, it's the same topologies, but there are some key differences between them. Namely, they cover a lot bigger distance. I mean, what was our maximum run on a piece of Cat5e twisted pair cable carrying Ethernet? 100 meters, 285 feet without boosting it, right? Wide area networks cover hundreds, if not thousands of miles. So they're a lot bigger, and they have a lot more users on them than what we would have in our private networks. Now, one basic technology we have is called a bus topology. And what this really is, looks like this. So here's my company, Husco Incorporated, the major international conglomerate, and I've got, 4 buildings here located in different cities. Well, what I might have between my 4 buildings are what's called point-to-point connections. These are WAN connections. And we'll see here in a bit, DSL, T1, T3. These are all wide area network connections being provided by some kind of provider. And they connect specifically one building to another. Well, if I connect my buildings together like this in series, that's a bus. It's just like the old bus topologies you saw with hubs, except it's spread over hundreds of miles, if not thousands of miles. If the South Oak Street office wants to talk to the First Street office, that signal has to go through the Main Street office, the Charles Street office, and then on to the destination. And the reply has to go back. Topology is easy. It's got some drawbacks. It doesn't scale very well. I mean, it's bad enough I have 4 buildings here. What if I have 40 of them? Right? I don't want site number 1 and site number 40 to have to cross between 38 other sites. It doesn't make sense. I might connect them together in a ring topology. Maybe I can do something like this. It's my bus topology, except I completed the circle. Right? And now I can go either way. If I want to talk to, from here on Oak Street to the Main Street building, I talk across here. If I want to talk from the Oak Street to the Charles Street, I could talk through here or through here. It all depends, right? I have 2 separate paths for doing so. This gives me some big advantages over the bus topology. If for nothing else, I have a choice of which way to go. And I've got a little bit of redundancy. Let's say this DSL connection goes down. Now I'm on a bus connection. But it's better than if it was a bus connection and this goes down, then this office would become isolated. Downside, I still have some scalability issues, right? As I keep adding more and more sites in here, it's more hops that packet has to make. Same idea. I have scalability issues. Well, one way to solve that is to do a star topology. Are you seeing the parallels here between LANs and WANs? The same topologies. It's just on a bigger scale. That's all that it is. And as we'll see later on, different protocols. I could use my star topology like so. This is kind of what a topology in a switch network on a LAN looks like, except in this case, instead of a switch, I've got a building. So maybe 2110 Main Street is my headquarters. Yeah, it should be. It's a big, tall office building. And these other ones are branch offices. So what I do is I have, instead of having the offices connect to each other, everybody connects back to the main office. Well, that solves lots of problems. I can scale out, and actually quite a bit. Arguably, my performance is going to be better. I have fewer hops to get anywhere. I mean, if I stick with the star topology, the furthest hop I have is 2. 1, 2, 1, 2, and so forth. There is a downside, though. Can you see it? Yeah. If the center of my star goes out, nobody can talk to anyone else. Is it worth it? I don't know. Well, a way to fix that problem is to do a mesh topology. We saw these on LANs also. I have 2 kinds of meshes, full mesh and partial mesh. What happens in a full mesh is that every building is connected to every other building. Wow, I've got lots of redundancy now. I can have multiple paths. If somebody goes down, I can go around the other way. All kinds of stuff. Okay, cool. Disadvantages to this? Well, not the least of which is expensive. That's a lot of WAN connections. And we're going to find that WAN connections are, for enterprise, are a lot more expensive than they are for just home connections, right? So I got a major expense in here. My other expense is also scalability. At some point, I'm going to have this patchwork of, it's going to look like a fabric of all these connections going back and forth across. One way to fight that is to use a partial mesh, where all the buildings kind of tied to each other, but not every single possibility, right? So I got direct connections here and here and here. It's almost kind of like a ring topology that doesn't go all the way around. Maybe my Indianapolis office over here doesn't need a whole lot of connectivity, doesn't really need to talk to these other offices too much, so I'll just connect it directly to Du Bois. Well, maybe. I could use a tiered topology. This is right out of designing switched networks for our LANs. Tiers. I don't mean like tiers like wah. I'm talking about tiers. Here's a tier, here's a tier, and here's a tier. So if these are headquarters or regional offices, and these are little branch offices, well, what I do is I connect my headquarters and regional offices together in a bus, and then I connect my regional offices to each branch office, rather each branch office to a specific regional office in a star topology. It's kind of a hybrid thing. Well, this buys me a few advantages. The biggest one is this is super scalable. This can go ginormous, right? I could even complete the ring. I could turn around, connect all the way back around here. Now I have a ring topology and a tiered topology. It really comes down to what my needs are and what my budget is, how deep my pocketbook is. Well, we looked at the different types of topologies, how we can hook our WAN sites together. Let's look at how we're going to hook our WAN sites together. The most fundamental way, the oldest way of doing it, is plain old telephone network. POTS, otherwise known as Public Switch Telephone Network, PSTN. MABEL, the phone, right? Just using phone lines. Originally, this was done using dial-up modems. Right? Remember those things? 56K modems? Boop, boop, boop. Right. Those things truly are modems. Modulators, demodulators. We talked about that weeks ago. And there's still a place for this. Right? A lot of times, dial-up is used for backdoors, for out-of-band access for things like routers and switches and stuff like that. There's other types of signals that can make use of the phone lines, though. One of them are T carriers. Now, after dial-up, there was this thing that came around called ISDN. And what ISDN was really 3 phone lines. It was like 2 data lines and a control line. And a lot of people back in the 90s, well, if you had money, you got this to your house. And you got like a blazing 64 kilobits down speed if you use all 3 lines. If you use just one line, you just got regular dial-up speed. And that was great, and a lot of people had it, but it was expensive, and yeah, you know, it was replaced by better technologies. But that concept stayed around. The T carriers are just an expansion of the ISDN standard. In fact, ISDN is right here. Signal level DS0, there it is right there, 64 kilobits per second, 0.64 megabits, is exactly that. And if you take 24 of those and put them together, you end up with what's called a T1 connection. Right? That's 21 phone lines put together, is really what it is. Look at my down speed on that, 1.5 megabits per second. For years, that was the standard. If you got 1.5 megabits down or faster, you were smoking. You were really going. That was a fast, good, stable, fast WAN connection. And it's still out there. The standard's still out there. It's grown, right? I can have T2, T3, T4, T5. These are just adding additional lines to my connection. And as I add additional lines to my connection, my overall throughput increases. Look at T5. By the time I've got 240 T1 lines going in there, which is really 24 ISDN lines, I've got 400 megabits of throughput. That's fast, even by our modern standards. Let me tell you something. It's also expensive, even by our modern standards. But it is there, out there. Anytime I have a T carrier, I'm connected to some type of T1, T2, T3, whatever, I connect to it through a device called a CSU DSU. And you're looking at it. Technically, this is 2 devices, a channel service unit, data service unit. It's combined into one as one single appliance. And a lot of times it will look just like this. Right? So here's my internet connection. Here's my T carrier. Many times these are phone connections. Right? It can also use other mediums of coming down too, fiber optic, whatever. But it contracts into some type of jack, some type of patch panel, if you will. That in turn plugs into my router with the CSU DSU. And my translation, my multiplexing for my phone signals, because notice right here, in this case, this is a phone signal because I'm also sending my plain old telephone system out through there. Out that goes. And I've got another device right here that sends my data network through it. Right? Other techniques certainly existed. Another one that's been around for a while was frame relay. And it was really a takeoff of ISDN. Now what frame relay did is replace layer 2. Frame relay is its own layer 2 protocol. A connection-oriented protocol, which means you basically establish a connection. You had a dial-up. You call it's not dial-up per se, but it's the same idea. No connection whatsoever. I call the other site picks up, and there's my connection. One of the advantages of frame relay was that I didn't have a straight monthly cost. I paid for the amount of bandwidth I used. Sound familiar? Well, if you're old enough, it sounds familiar. That's how the phone service used to be. You used to pay for your long distance time by the amount of minutes you were connected to it. This worked along the same way. Another advantage is compared, especially to the T carrier, it was way less expensive. Another way that should be familiar to many of us, digital subscriber line, DSL. A version of this is a consumer product, and we'll take a look at it here. Another protocol that operates over POTS, the plain old telephone service. This goes across phone lines. It is technically a modem, multiplexer, demultiplexer, and I have multiple types of data. I got my voice channels, I got my data channels, all going across that single copper phone line. Or fiber phone line, for that matter. This is a layer 2 protocol. It doesn't really matter what's going on layer 1. I have different kinds of DSL. The two main differences is what's known as symmetrical or asymmetrical. Symmetrical DSN means my up speed and my down speed are exactly the same. So if I subscribe to 3 megabits symmetrical, I get 3 megabit upstream, 3 megabits downstream. Asymmetrical means that I download, generally speaking, I download faster than I upload. So I might have 3 megabits going down and 768 megabits going up. Where have we seen this before? Asymmetrical DSL, ADSL. That's the consumer grade product. You can get symmetrical DSL. However, what do you think is more expensive? Yeah, the symmetrical DSL. Most small businesses or home users or something like that, they don't have a large requirement to upload. Well, arguably not as much as downloading. And I can get it far less expensive by doing an asymmetrical DSL. And if you sign up for it, that's what you have usually coming into your house. For all its advantages, DSL, any type of DSL, has one major drawback, and that is my limit. I can't have a DSL connection more than 18,000 feet from a telephone switching station, which is the provider's switching station. A lot of times these switching stations are little cinder block buildings off the side of the road somewhere. But 18,000 feet, 5,283 feet to a mile, that's about 3 miles, right? So if you're signing up for DSL, one of your big limitations is, are you within range of the 18,000 feet? If you're not, DSL is simply not an option for you. And that wraps up the first half of our discussion on wide area networks. When we come back, we're going to continue this, and we're going to go and look at other types of, especially very common WAN technologies like cable and all that, stuff that we're very familiar with. I'll see you in a few minutes.